Today we're looking at partial fractions, a technique for breaking a complicated rational function into simpler pieces we can actually integrate. The rule is this: for a distinct linear factor, like x minus a, you get a term a divided by x minus a. For a repeated linear factor, x minus a to the n, you get a whole sum of terms, a1 over x minus a, up to an over the quantity x minus a to the n. And for a distinct irreducible quadratic factor, you get a term of the form ax plus b over that quadratic. But before any of that, there's a crucial check. This decomposition only works for a proper fraction where the degree of the top is less than the degree of the bottom. If it's not proper, you must do polynomial long division first. Let's work through an example. We want the integral of the quantity 3x plus 5 divided by the quantity x minus 1 times the quantity x plus 2 dx. The top has degree 1 and the bottom has degree 2, so this is proper, and we can decompose it directly as a over x minus 1 plus b over x plus 2. Multiply both sides through by the denominator, the quantity x minus 1 times x plus 2 to clear the fractions. This gives 3x plus 5 equals a times the quantity x plus 2 plus b times the quantity x minus 1. Now substitute x equals 1, which makes the b term vanish. The left side becomes 3 times 1 plus 5, which is 8, and the right side becomes a times the quantity 1 plus 2, which is 3a. So 8 equals 3a, giving a equals 8 divided by 3. Next, substitute x equals negative 2, which makes the a term vanish instead. The left side becomes 3 times negative 2 plus 5, which is negative 1, and the right side becomes b times the quantity negative 2 minus 1, which is negative 3b. So negative 1 equals negative 3b, giving b equals 1 divided by 3. Now we rewrite the original integral using these values as the integral of open bracket 8 over 3 divided by x minus 1 plus 1 over 3 divided by x plus 2 close bracket dx. Integrating each simple term separately, the integral of 8 over 3 divided by x minus 1 dx is 8 over 3 times natural log of the absolute value of x minus 1, and the integral of 1 over 3 divided by x plus 2 dx is 1 over 3 times natural log of the absolute value of x plus 2. So the final answer is 8 over 3 times natural log of the absolute value of x minus 1 plus 1 over 3 times natural log of the absolute value of x plus 2 plus a constant of integration. The trick that makes this method so quick is choosing your x values cleverly. If you substitute the root of one linear factor, the other factor's unknown term multiplies by 0 and vanishes. So instead of solving a system of equations all at once, you solve for each unknown separately, one simple substitution at a time. The most common trip-up is forgetting to check whether the fraction is proper before decomposing. If the top's degree is greater than or equal to the bottom's degree, and you skip the long division, the decomposition you write down will not actually equal the original expression, even though the algebra looks fine. So here's a teaching tip. Before you write any decomposition, explicitly compare the degree of the numerator and the degree of the denominator, and write the word proper or improper right next to the integral. If it's improper, do the long division first, as its own separate step before you ever set up the partial fractions.